Imagine standing in a jungle so hot it feels like the air itself is alive. The ground is damp, heavy. Every sound is muffled by thick, endless green. Then, the water moves, not with ripples, but with weight. Something enormous slides beneath the surface, slow, deliberate, unstoppable. You don't see it at first. You feel it. Because in this world, nearly 60 million years ago, the largest predator wasn't a dinosaur. It was a snake. To understand Titanoboa, we first have to understand its world. After the dinosaurs vanished, Earth didn't calm down. It overheated. The planet entered a period of extreme warmth, far hotter than anything humans have ever experienced. There were no ice caps. The air held more moisture. The jungles were thicker, darker, and endlessly alive. This wasn't just a rainforest. It was a pressure cooker for evolution. And in this heat, cold-blooded animals didn't just survive, they expanded. Snakes, unlike mammals, rely on the environment to control their body temperature. The hotter the world, the larger they can grow. Titanoboa was the result of a planet turned up too high. But this raises a larger question. If heat made giants possible, where was the limit? Titanoboa wasn't just big, it was wrong by modern standards. Over 40 feet long, weighing more than a small car, so massive that its own body would struggle to move on land. And that's the key. Titanoboa didn't hunt like modern snakes. It didn't need speed. It lived in water. Rivers became highways. Swamps became hiding places. Instead of striking fast, Titanoboa likely waited, motionless, invisible, until prey wandered too close. Fish the size of crocodiles, early mammals, even giant reptiles. Its body wasn't built for chasing, it was built for pressure. Scientists believe its muscles could crush prey with forces beyond anything alive today. But there's something unsettling here. We don't know exactly how it hunted, because no living animal moves quite like Titanoboa would have. In Titanoboa's world, there was no apex predator above it, no rival big enough to challenge it, no environment cold enough to slow it down. This snake existed at the absolute top of the food chain. And when a predator reaches that level, evolution changes. It no longer needs speed, or camouflage, or venom. Size becomes the weapon. But size comes with a cost. Titanoboa's body would have required enormous amounts of energy. That means it didn't eat often, but when it did, it changed the ecosystem. Entire food webs bent around its presence. Yet here's the mystery. Despite its dominance, Titanoboa vanished. The climate cooled, temperatures dropped just enough, and suddenly the world could no longer support something that large. Which leads to an unsettling thought. If a few degrees decided Titanoboa's fate, what else is quietly balanced on that edge today? Titanoboa isn't just a fossil, it's a warning written in bone. Its existence proves that Earth can produce creatures far beyond what we consider normal. That size, power, and dominance are not fixed limits, but temporary conditions. Scientists still don't know how many other giants existed alongside it, or how many ecosystems were shaped and erased before humans ever appeared. And the deeper we study Titanoboa, the clearer something becomes. This wasn't a monster, it was a mirror, a reflection of a planet pushed to extremes. Today, we look at Titanoboa and feel safe knowing it's gone. But the forces that created it, heat, time, evolution, those never left. They're still shaping life in places we haven't explored, in jungles we haven't mapped, in oceans we've barely touched. Titanoboa reminds us that Earth doesn't create creatures for our comfort. It creates what the world allows. And sometimes, what the world allows is something far bigger than us.